Good morning, good afternoon, good evening. This is Mr. Payne bringing you the last video of the year for review, regressions, residuals, and correlation coefficients. Let's talk about the three pictures that you see right up front here. Each picture is a scatter plot, and with each picture they should have a line of best fit drawn. So this first guy, linear, y equals ax plus b is the formula, or mx plus b, however you want to remember it, has a line of best fit already drawn through. The next one is a quadratic. It is in the shape or design of a parabola that has a maximum value, which is your vertex is up at the top. So if you drew your quadratic best fit, it would look like the following. And the exponential, y equals a times b raised to the x power. This is demonstrating a decay graph. Okay, and your exponential growth or exponential best fit would look like that. You want to remember that your line of best fit is drawn through the middle of your points. It's not touching or connecting your points for drawing the line of best fit. How to get the equation of a line of best fit? Well, you don't have to so forth to grab or see your points. If you're given data points on a graph and not in a table, then you would have to pull them. But sometimes I think that may be a little complicated with the scatter plot because your scales aren't the greatest. Most of the times they're going to give it to you in a table. So enter your data points into L1 and L2. Notice that you're using L1 and L2. Okay. Then you're going to hit, you type that in by hitting stat enter, or stat, we call it as edit, right? So we know it as stat edit. To find the equation, hit stat calc, so that's what that right arrow means, so stat calc, and then number of regression. So your linear, you're going to hit 4. Your quadratic, you're going to hit 5. And your exponential, you're going to hit 0. So linear is 4, quadratic is 5, and exponential is 0. Those are what you're going to hit: stat calc 4, stat calc 5, or stat calc 0. To rate it with the correlation coefficient, what does that mean? Well, how accurate is your line of best fit? The way to do that is by turning on your diagnostics. Okay, turn on your diagnostics, and you'll do that by hitting second 0. Scroll to diagnostics on and hit enter. You want to keep hitting enter until it says diagnostic on and done. Okay, once that says that, then you could type in your data just like we did before and hit stat calc 4, stat calc 5, or stat calc 0 to get to your R value. Your R value, not the negative R value, the R value. Okay, and it's -1 to +1. Remember that those are your stronger. The closer to 0, the weaker it gets. So let me draw you a little picture of what that looks like. So we're going to be super strong over here and super strong, positive basically, or perfect basically. And then as you move closer to 0, the weaker you get. And the same thing goes in this direction. 0 is absolutely horrible. So you could also tell by looking at your picture. Something that is a -1 or a +1 is going to be a perfect scatter plot. Really tight. As you get closer to 0, you may see some type of pattern, but it's really far apart. So that's what the difference is. So the tighter your points are, the stronger your correlation, both positive and negative. The farther apart they are, the weaker your correlation is. And all that means is if I draw a line, if I draw a line of best fit here, and I drew it through the middle, how accurate is that? How accurate? I may be off a little bit in any regard, so therefore my line may not be as accurate. If I have my points really tight together, I know my line of best fit where it's going to go because it's accurately going through. The last topic we're going to talk about is residual graphs. Your residual is how far the data points are from the line of best fit. So, if there's a pattern, a true scatter diagram is a good pattern, a good fit. So that means I drew the right line best fit with the correct linear regression. If it's bad, it's going to show a pattern. In this case, it's showing some type of pattern of a quadratic. Therefore, it's bad. What that's measuring is this. So if let me draw a scatter plot again. Let's make my lines a little thicker so you can see my dots a little bit better. And I draw my line of best fit through that. What this is measuring, okay, is how far this point is away from that. How far this point is, how far this point is, how far this point, this point, this point, this point, this point, okay? That's what that's measuring, the residual. How far the point, the data point, is away from your line of best fit. If I drew the line of best fit accurately and I picked the right type of regression, it's going to come out as good. If I did not draw it properly, it's going to come out as a bad. Or if it's a bad correlation, or if I pick the wrong model, it's going to be a bad residual, a bad line of best fit. So I hope you understand the difference a little bit and what a residual is, because we're definitely going to use this on the test. This is a huge part of your final exam and understanding the regressions and being able to use that information for arithmetic sequences and linear type functions. This is a big part of your exam using your calculator. So I hope you're the best, and good luck on your final exam.